Okay, so this is section 1.8 in my pre-calc trig class. Is combination functions, composite functions. I just have composite functions up there, but it's combination of functions. So what this is doing is saying if we have f of x and then say g of x, we add them together, subtract them, multiply them, and also divide. That should be pretty simple. The hard part of the tricky of this is f of g of x, or as I like to call them fog and goff, g of f of x. And I'll go over some examples of those ones. But first, what the key notes you need to have, if we're looking at the sum, it's going to be written parentheses f plus g parentheses x. This is kind of confusing. The x is not being multiplied, it's on the outside. So I'll do an example with numbers. So it's like f plus g 1. That means 1 goes in for all the x's. But this turns out to be f of x plus g of x. Okay, so it would be like f of 1 plus g of 1. In that my example I used. The next one is difference, f minus g of x, which is f of x minus g of x. This one I make sure I show because there's parentheses, because you have to just shoot that negative. Most students forget the first time through, and they get their answer wrong and they wonder why. So you got to make sure you just shoot the negative. The next one is product, f times g of x. So that's f of x times g of x, as you can see. The last one is f divided by g of x, and that's f of x over g of x. But g of x must not equal 0, so you got to find the domain. Still, students always struggle with domain, and I don't know why. Well, I do know why. It is kind of tricky to grasp, but there is some simple rules which I believe I covered in 1.4 or 1.3, something like that. And then the last part of it, so this is the combination part. This is the composition part. It says f of g, so this is like a little o. It's really hard to see. It's not a dot though. That's why I call it fog. Fog is f of g of x. That means I'm plugging g of x into my function of f. And I'm going to do some examples of that one so you get the idea behind it. But that's the big part of this chapter. Tricky note with these is the domain of f of g of x is the same as g. So f of g of x takes on the domain of what the function I plug in. So again, here's the basic of the notes. I'm going to go through some examples of all of them, and that'll be it. It's relatively a quick and simple lesson. My advice is don't overthink it. Okay? So if you need to pause it, I'd pause it. Okay, and our first example. For number 10, we have find a, f plus g of x, find b, f minus g of x, find c, f times g of x, and d, f over g of x. Given f of x and g of x, and it's going to be different for each one. So basically what we're going to do is just go ahead and do what it says. So it says f plus g of x. That means we're going to have 2x minus 5, because that's f of x, right? Plus 2 minus x, because that's g of x. Go ahead and distribute. So that means the positive it stays. So 2x minus x is going to be x, right? Okay. And then minus 5 plus 3 is plus 2 is going to be minus 3. And that's the answer for that one. And that's all you do is just add combined terms. This one, remember it's f of x minus g of x. So that's going to be 2 x minus 5 minus 2 minus x. And this is where the parentheses comes in handy. You've got to make sure you distribute the negative to the second set. So we're going to have 2x minus 5 minus 2 plus x. Combine like terms, and we should get 3x minus 7. And that's the answer there. Okay, so you've got to make sure you distribute that negative. That's the key part. Most students miss that, or they forget to do that. Next is we're going to multiply them together. So we get 2x minus 5 times 2 minus x. We have to FOIL. Okay, so we're going to start doing foiling more in class. Usually the further you go in math, the more complicated you do, and the more foiling you're going to do. So you got 2x times 2x, or 2x times 2, which is 4x. 2x times negative x, which is negative 2x squared. Negative 5 times 2, which is negative 10. And then negative 5 times negative x, which is positive 5x. Combine like terms and rewrite it to greatest common, or rewrite it proper. And we get negative 2x squared plus 9x minus 10. Okay, so that's our final answer there. This last one, I'm going to come all the way over here and do it. It's f over g, so 2x minus 5 over, it's 2x minus 5 over 2 minus x. Now we can't reduce it because we have the plus, the minus there. The last thing we need to do is find the domain of g of x, which is the bottom. So find this domain, find domain. So 2 minus x equals 0. Solve it, so x cannot equal 2. So here is our total answers. Okay, and that's the basics of adding them together, just x. All right, so if you need to take notes, take notes. I'm going to erase this, and we'll do another example. We've got 2 more examples, one with the numbers in it, and then we'll do an example of f of g and g of f. Okay? All right, the last examples we're going to do is 1741. Let's start with 17 first. 17 is evaluate the indicated function for f of x and g of x and for the value. Okay? So what this is, before we've had f plus g and then x on the end. Nothing's really changed except now we have a number. So there's a couple ways to go about this. How I like to do it, since I know I'm going to add them together, it's just x squared plus 1 plus x minus 4. Okay? So if it was just like normal, we just add them together. But now this is where the 2 comes into play. We're going to let x equal 2. That means plug 2 in. So find f plus g when x equals 2. So if we plug 2 in, we're going to get 2 squared plus 1 plus 2 minus 4. So now we just do some math, and we should get 4 plus 1, which is 5, plus 2 minus 4, negative 2. And our answer is 3. So basically, all you're doing, if you have problems like this, is you're just plugging in the number into the x's of what the equation is. So like I did this first, and plug 2 into all the x's. You can plug 2 in first, and then add them. It's up to you. It's how you want to distinguish it. So that's the combination of functions. Now, 41 deals with the composition of function. And we have f of x equals the square root of x plus 4, and g of x equals x squared. Part A wants us to do f of g of x. So it says FOG, which that means f of g of x. So we've gone through before in previous sections, we've plugged in numbers. We say f of 2. We plug 2 in for all the x's and get a value. So nothing's changed here in terms of that concept. We're plugging something into x and getting a value or getting another equation. That's really what's going on here. So what g of x is x squared. So basically we're going to say, well, f of x squared. So that means we're going to plug an x squared into all the places we have an x in our f of x. So this is going to look like the square root of x squared plus 4. That's all that's going to do. And the question is, can you reduce it? In this case, you can't. The square root does not go to each terms individually in terms of addition. So you're done. This is your answer. The next one is g of x. So we're going to plug in. So this looks like g f of x. So what's f of x? F of x is the square root of x plus 4, so we get g square root x plus 4. So wherever I see an x, I'm going to plug in the square root of x plus 4. So that means we're going to get the square root of x plus 4 squared. Now, the squared cancels the square root in this case, so our answer is just x plus 4. So here is our answers for those. So again, it can be complicated if the student likes to make it complicated. I always say, the slower you make it complicated, the faster you're going to fail. This is the big concept, I believe, is plugging an equation into another equation. That's the concept that goes on into the business world and more real-world applications. I'm trying to think off the top of my head and I can't. Sorry, drawing a blank. But what we have is you just plug this g of x, that g of x squared, into all the x's of your f of x. And that's what we did here. And we got x squared plus 4. G of f of x, we plug all f of x, the whole thing, into the x's of the g of x. I know this was a simple example. I always say if you need help or if you have comments, you just leave them in the comments. I'm usually really good about checking them. But that's how you do those. Hopefully that helps with section 1.8. I didn't cover everything, but that's the basic of it. So hopefully if you're on 1.8, you should be good to go. And that's it.